Hello. Today we're going to be talking about how to go from a graph of f prime to a graph of f. This will involve delicately reading f prime's graph to find out information about f's graph. Specifically, the y values of f prime will become the slope of f, the slopes. If these y values are greater than 0, if the graph of f prime is above the x-axis, f will have a positive slope. The y values will be increasing. I went over this at the end of the last video. I'm serious when I say I cannot repeat this information enough, it seems. If the y values are less than 0 of f prime, if the graph of f prime is below the x-axis, f will have a negative slope, meaning f will be decreasing. If the y values change sign from negative to positive, therefore that will mean f changes from decreasing to increasing. That means we will have a relative min. If the y values change sign from positive to negative, that means f will change from increasing to decreasing, meaning we'll have a relative max. This is possible with crossing x-axis or having a discontinuity that moves us between the positive and negative parts without crossing it directly. Blah. The slopes of f prime, on the other hand, will tell me the concavity of f. A positive slope on f prime, the y values of f prime increasing. F prime is increasing will mean f is concave up. F prime is decreasing will mean f is concave down. If f prime achieves a relative max or min, it will mean that f has a point of inflection. This is all because basically these two parts of the table shift over here, and the y values of f double prime are encoded as the slopes of f prime. You can rewind this and listen to it as many times as you need. I highly recommend it before we do the next example. Okay, without further ado, here we go. Now, throughout this video, I'm going to use circles for x-intercepts. Okay? And I'm going to box any relative mins and maxes I see. Just to help me keep organized. I'll probably use different colors, so let's just pick a different color than red. Blue. So I see a few x-intercepts here to start off with. Here, here, and here. This is a little bit of cheating. These x-intercepts, like I just said in the last slide, will be possible relative mins and maxes. They're places where I touch the x-axis. So these x-intercepts will go right onto my f prime number line. So we'll say that's like 3.5. That's positive 3.5. I'm using a closed bracket type notation to signify that I don't go past this. These are solid dots. Here's an x-intercept. It's going to go right onto my f prime number line. Especially because this is a place where I cross the x-axis. Now, if you were just paying attention, this means that this is a relative max or min. Which one? I'm going to look at the sign of f prime's y values to understand. Remember, this is an f prime number line. So is the sign of f prime positive or negative before 0? F prime is positive. F prime is above the x-axis. Then we're at 0. Then F prime switches to being negative. F prime switches to being below the x-axis. So negative. And again, if we're going to put guidelines, increasing behavior for F, followed by decreasing behavior of F. Now again, this gets very confusing. People look at this like, whoa, 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 whoa. It doesn't look like that. Yes. These guidelines are about how F looks. We're going to box the relative mins and maxes because they are possible points of inflection. We're also being bounded between these two. And again, I'm going to try to line things up with 0 in the middle, -2 right here, +2 right here. So for F double prime, I'm going to be looking at the slopes of F prime. The slopes of F prime are positive because F prime is increasing. F prime is increasing. Its slope is positive, so F double prime is positive. Concave up. Now it's concave down. We're talking about what F has here. Deep breaths. Between -2 and +2, F prime is decreasing. F prime is decreasing. So the slopes of F prime are negative. So F double prime is negative. Concave down for F. After 2, F prime is increasing. The slopes of F prime are positive. The derivative of F prime is positive. So F double prime is positive. Concave up. So we know 0 is a relative maximum. We also know we were told to starting point of 0, 1. So I'm going to make sure I hit that point. I'm going to fit some concavity shapes onto my guidelines. So starting down here, we want to be concave up and increasing. Don't dip down. If you think that dips down, it doesn't. Don't do that. That would be decreasing. Bad, 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 bad. Increasing. Switch. Now we're concave down and increasing. Stop. Now we're decreasing, but still concave down. Now we're concave up and decreasing. Don't switch, don't go like that. That would be concave increasing, concave up increasing. Just like that, just die, just stop right there. How very symmetric. I'm not going to judge your symmetry. It could look like that. We don't know. Probably doesn't look like that, but we don't really know. Start with a harsh endpoint right here. At -3.5. I will look for an arrow. Do not make an arrow. You don't know. Concave up, increasing. Until we get to 2, -2. Now we switch to concave down, but still increasing. We have an x-intercept, that's fine. We don't know. I hit that point. I have to. It's a starting point. It doesn't mean you have to start graphing there. Graph on both sides of the starting point if you know. It just means this is a height we have to hit. Don't listen to the starting point as you starts to the right of that. Both sides. Now concave down and decreasing. until we get to positive 2. And then we switch to concave up and decreasing until we get to positive 3.5, and we stop. That's one possible answer. F prime is positive from negative 3.5 until 0. F prime is positive, so F is increasing. Check. F prime switches to negative, so F is decreasing. Check. F prime is increasing, so the derivative of F prime is positive, so F double prime is positive. Concave up. F prime is decreasing. The derivative of F prime is negative. F double prime is negative, so we're concave down. F prime is increasing again from 2 to 3.5. Since F prime is increasing, the slope of F prime is positive. F double prime is positive. Concave up. This is one possible answer. Another possible answer, not necessarily true, would be having everything be positive. But it's much harder to show all this behavior. Switch. Don't do this at home, kids. Okay? Give yourself space. Again, you don't know if that's true either. Well, you go here. Again, the more exaggerated you have it, the harder it's going to be to draw. Concave up, concave down, I guess. I would like to see it a little more emphasized. I'll try to reflect on that. Stop. Okay, I like the one I drew best. That's what's most natural to me. We don't know if it has x-intercepts. We don't know anything about the y values except at the starting point. In case you can't imagine what I'm talking about, some students do that because they imagine they have to start here. You know the behavior left of 0. Show me that behavior. Enough said about this problem. X-intercepts, circle, box relative min max. All right, culminating problem. Graph F prime, use F prime to graph F and F double prime. Look, if you want to pause this video and try examples 5 through 8 right now. Problems 5 through 8. On page 76. That would not be a bad idea. Go ahead and try it out. Actually, yeah, I'm going to end the video here. Try those problems out. I think there'll be a better incentive. Okay? Go try those problems out now. Work out your kinks with them. Ask me any questions in person. Good luck. Have fun with those 4 problems. Blah. See? Should pause the video now anyway. Have a great time. Good luck. Bye-bye.